about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello everyone, and welcome to the fourth meeting, I think so. The fourth meeting of the C++ Digital Signal Processing JUCE study group. And with me is Fotis, other side, Fotis.
Hey.
As well as Cwits. How are you doing?
Hey.
So we were just talking about our experiences these 2 weeks with the tools we decided to use. So Cwits was talking about the value of recreating things sort of from scratch. So how is your thing coming along? I remember that you were sort of creating everything from scratch so that you could connect your Ableton Push to a Raspberry Pi, and you were going to do that bridge between the audio processing part and the controller part. So how is that coming along, and how are you liking the tools you decided to use?
I think the tools is pretty good. I'm using, for example, VS Code, Visual Studio Code for the coding, and I'm started recently to use CMake to build everything together. And for now, it works just good. I think more than good. It's great. So I'm pretty happy with it.
And are you configuring CMake yourself, or are you using something that creates configuration for you? Because I think that
I'm trying.
There are projects that do that, right? That help you come up with a CMake configuration.
I'm trying to configure CMake by myself because it's part of learning. I want to know how it works.
Are you doing anything fancy besides just pointing CMake at the source files and telling to invoke the compiler, or are you doing something interesting in the configuration?
What is something fancy?
Like, you could, I guess, use CMake to fetch dependencies, because I know you're using that library to communicate via USB with the push device. So you could try to fetch dependencies using CMake, or you could use something like Git submodules. And I'm sure that there will be abstractions in CMake to run tests, and I mean automated tests, unit tests, that sort of thing. And
really?
Yeah, it comes with CTest. It's CMake, CTest. It's actually a suite of things, of tools in the package, developed by the same group, I think. And that's when it gets fancier. But it seems like you're not using any of those. You're just mostly telling it to invoke the compiler and the linker and build yourself an executable.
No, finding of packages or some modules, I'm using it. For example, for jack audio, for streaming audio in my Raspberry, inside and outside. Some other modules also, for example, SND file for working with the audio files, especially WAV files, and it finding them by himself and to work. Yes.
And what?
But nothing more.
Okay.
I didn't know about tests and maybe how to have to
Cwits, I have a question.
Yes.
You mentioned jack earlier. Have you ever used a different thing like pulse audio or pipe wire?
I know about them. There is a couple of I don't know how they called audios processing, not processing, but libraries to work with audio streams. There is also Jack. What else?
ALSA.
And a couple of others. I have heard
ALSA.
about them, but I don't know. Maybe I have tried to watch ALSA, but it's more complicated than Jack.
Mm.
And Jack is built on the top of ALSA.
Oh yeah, you're right. I didn't know that.
As far as I understand, Jack is kind of an abstraction because it works cross-platform. You can use Jack in macOS, for instance, and then it will not be using ALSA. It will probably be using Core Audio, right?
Maybe. I don't know about Mac and the other platforms.
Okay, fair enough.
I posted on the chat a video by Unfa where he says
yes.
he replaced. Yeah.
And
he replaced Jack and pulse audio with pipe wire.
I actually have a question circling back to CMake, because I tried to find some quick tutorials just to get my feet wet, and I couldn't find anything that I liked that was at the right level for me. Not too advanced, not too introductory. Do you have any materials that you'd like to share? How are you learning CMake?
Basically, almost all of materials are in Russian language, so I think it will be hard for you to understand.
It probably will.
Just in my native language, so for me it's easier to learn from them.
Nice. Now it's time to talk about my progress.
Yeah, I mean, but before we do that, I want to say hello to Bo, who is watching, but he couldn't join the call. But he says that he has been doing a number of JUCE tutorials, and he is getting started, but it's different from everything he has done. And he has a question. What does double column means in C++? So column. What does that mean in C++?
I don't know how to properly this thing is named, but it's like a scope resolution operator. For example, if you have different namespaces to operate with, you have to add namespace name, then use double column and the function from that namespace. Maybe it will be easier to show in code.
Yeah, do you want to share your screen, or do you want me to share my screen? Because I have C++ code here that is using that operator, and we can talk about how it's used.
Feel free to.
Okay, so give me a moment as I press buttons on my side.
Oh, by the way, hi, Bo.
Oh, no.
Hello.
The buttons I had to press, they are not working well. My cursor is going crazy.
I can share my screen also.
Okay, it seems like something is happening. It seems like I am sharing my screen now.
Yes.
Go figure.
There is some weird noises.
But everything is all right. I mean, you can all see my screen. The stream is able to see my screen. Great, okay.
Hey, it's the auto mixer.
Yeah, that's the progress that I will share later, but we can talk about
Awesome.
this operator because it is here all over the place. So I think that it actually means different things. For instance, I have here a plugin processor class where I have a method called process block. That's where it gets interesting, right? That's the method that is taking audio as input and needs to compute what the output will be. That will actually do the auto mixing in this case. And I am here in this file saying that there is a class with this name and a method with that name. This is just a header file. It's just declaring what the class and the method names are. But then in the implementation, there is this occurrence of that operator where I am just saying, I guess it's sort of a namespace, but not as a namespace in C++, because C++ has a namespace. It's a keyword. It's a concept in C++. But in this case, it's just saying I want to define the body, the implementation of the process block method from this class. So this is an occurrence of that operator. So that in this context, and this is probably the place you're going to see this the most. In this context, this is what the double column means. But it also appears here, and I guess in this case it is a namespace, right?
Yes, this is namespace.
Yeah, I can command control click, and then I can show the definition of where this comes from. It's actually from JUCE, and in this case it's a namespace. And then over here there will be a class under that namespace. So if I want to refer to this class, I will use something like JUCE column, the name of the class. So
yes,
the operator may
right.
mean different things in different contexts, but I guess these are the two most common uses to separate the class and the method in the class, as well as the namespace and whatever is in the namespace, like a class.
Yes, you're right. These operators are used also when you're writing static functions for class, because you cannot refer to the static function from the object, but you have to use it like for whole class. And then you will write your class name, column, and the function name.
Yeah. That's a good point. Let's see if I can do that
something
here.
Something similar.
I think that there is something like that has to do with DB computation, and that's a static method in JUCE, but I don't really remember the name. Yeah, I don't think I would be able to find this. But in that case, I guess it boils down to the same thing. It's just, suppose that there is a class called DB conversion, and then you would call a method in a static method. So I don't have an instance of an object called DB conversion. This is literally just a class. And then I could call a method like, say, DB to gain.
Yes.
And then I would expect this to return
right.
0.5. Something like that.
Something like that.
I guess in C++ it's common for one piece of syntax to mean different things in different contexts. I hope that answers the question, Bo. So, Fotis, do you want to share your progress?
Yeah, you're not going to believe this, but I got stuck again. So yeah. I think I have some problems with Visual Studio, and I think that I'm going to switch over from JUCE to something else. Have I mentioned in a previous stream the framework called Cabbage? This is also using CMake, but I have run it. I'm going to post the link in the chat. You can download the latest version. And this thing is much easier to use because it has its own editor. It doesn't require you to run Xcode or Visual Studio. It has its own building engine, and I have found tons of open source plugins with C sounds with the extension .csd, and I have found lots of both instruments and effects on GitHub. You can download the CSD files, load them into Cabbage, and then export them as VST or AU or whatever, and they work. I tried them in Reaper.
Awesome.
And
so you were able to go through the whole process and generated a VST.
Yeah. And I think I should focus on that. Yeah, I know what Cwits said about limitations, and I agree. But I think that in my case, this thing is actually good because I'm not a programmer. And I think that this I have found enough with tutorials, so I think I'm going to switch over from JUCE to Cabbage. And the other reason why I want to use this thing is because there is a developer called Pure Magnetic. He has made many VSTs and also Ableton devices, and he has a record label. He likes to make experimental electronica, and he has made a GitHub repository called Lore, and then post. So yeah, this is what I'm good at. I'm not good at coding, but I'm good at finding various links, and I guess I'm the research guys, and I'm leaving the heavy coding to the heavyweights like you guys. But yeah, Lore is a great repository of effects that showcase what you can do with Cabbage, and he has some very interesting things. This is a little sampler that creates sounds, and these spheres are actually moving, and you can automate them via MIDI. And the moving, yeah, they have a pretty minimalistic design, but you can create many other interesting things with Cabbage, like entire synths and effects. So I guess my objective for the next 2 weeks is to get started with Cabbage, unless I fail at that again.
So Cabbage is using C sound, and that means that you're not going to write C++. You're going to be writing C sound, which is its own, I guess, a domain-specific language, much like JS Effects is a domain-specific language. It's a programming language that is not general purpose. It is meant to do audio programming, I guess, in this case, synthesis, but probably some sort of processing as well. And
yeah, and if I'm not mistaken, Super Collider also uses C sound.
Okay. And can you point at some of these? You said that you found plenty of C sound source code. Can you show us one that you think is particularly interesting?
Yes. Hold on, because I found a lot. I'm here on GitHub. You can find it yours. I'm going to, if you go to GitHub and go to search, I'm going to show you the exact link so anyone can find all the CSDs, and then I'm going to show you what the specific CSD is called, because I forgot the name. Please bear with me. And before I find it, I wanted to mention something else about another interesting thingy that I discussed in a previous video. Remember that thing called DIN Is Noise? It's a synthesizer that is open source. You have to pay to get the builds, but if you download the source code and build it in Linux, it's free forever and legal. So I did that. I installed VirtualBox and I installed Ubuntu, and then I built DIN Is Noise, and it works. Of course, I have some latency, which is to be expected because it's a virtual machine. But thankfully, DIN Is Noise has an offline render switch. So you can export high-quality WAVs without having any sort of crackles in the renders. And the thing, I would like to make something like DIN Is Noise, but in VST form, because this thing is amazing. I've never used anything like it. Where is the advanced search on GitHub? Oh my God.
I suppose you're looking for something like this, right? This box here.
I want to filter the results by only using those that were made with C sound. Because, you know, yeah. Oh, wait. Oh, yeah, I found it.
Okay.
You have to
I actually don't know. I use
by...
the GitHub search quite a bit, but I don't think I know how to limit the search for a language. I'm sure it's possible,
yeah,
but I don't know how to
do it. If you scroll down, if you scroll down and see those colored thingies, I'm not here. If you go to the homepage of the repository,
okay.
you can go back. Yeah.
So you're just looking at the different.
This thing, yeah. Click
okay.
it.
Okay, I don't think I have ever clicked on that, but I do use this quite a lot to see what the languages are in the project.
Yeah.
And it's funny that GitHub seems to be identifying C sound and C sound document as different things. I don't quite understand why. In any case, you did send a link, and all the links I'm going to share later on that GitHub repository we all have, instead of having to copy them on the YouTube chat. But people on YouTube can just see what we are seeing together. So this is a list of C sound sources, and I wanted to look at one of them that you think is like it makes sense to you. So do you care to pick one?
Yes, and it's this thing right here.
Okay.
This thing has opcodes.
Okay, I can see that it is also picking up C sound and C sound document as different things. So in all of these folders, where should I go to?
I don't remember. I downloaded the whole thing. Wait a second, I'm going to sort my files.
Because my goal is just to look at C sound, to look at the source code and to maybe compare it to C++, JS effects, the other things we know.
Yeah.
It looks like more Python, I suppose.
Yeah, it does look a bit like Python, but almost all folders, if you go to strings and if you want to just look at the syntax, you can check out that other thing, that lore thing.
Okay.
Because this is more advanced. You can go to lore generative devices, Ember, and then download the CSD file.
That Cabbage link have some examples.
Yeah, here it
that
is.
Also
you can see the code here. If you scroll down,
yeah, it's this file here. Okay, so I can see that they are using Lisp syntax for comments. That's quite interesting. And over here, it seems like they are doing the graphical user interface, because that's another question I had. Like, what does the graphical user interface look like for plugins? But it seems like it's mostly like samplers, that kind of thing, for the most part. So
yeah, you can
knobs, waveforms, and a keyboard.
Yeah.
And sliders, and I guess an XY pad. Not bad.
If you go to line 62, this is where the real code begins.
Okay, so all of this was just, and you can edit this in an editor that comes with Cabbage, so it will do syntax highlighting and some sort of guidance as well. Not bad.
Yep. And the same editor is where you do the build.
Awesome.
So it's an all-in-one package.
I like how everything is in one file, like the compiler options are here.
Yeah.
It seems like compiler options anyway. Compiler flags, I guess. Okay, so this is allocating arrays, I suppose. This is using a window. It's not exactly clear to me what GI stands for, GK, but I'll take it.
Maybe it's C sound specific syntax.
Yeah. Yeah, it's very cryptic, because it is using, I guess, abbreviations or acronyms but I do think I understand what's going on in terms of like, this is handling graphical user interface stuff. So I guess there is an XY pad of some sort. I suppose it will look something like this. And then let's try to see if we can find any audio signal processing here.
This is a generator. I think it doesn't process audio.
What the hell?
But still,
You should ask Pure Magnetic about that. But yeah, he's using binaural processing. You can see the HRTF files.
Yeah.
And it's in DAT instead of WAV, which is also interesting.
All right. And how do you plan on using Cabbage in these sources that you found? Do you want to do, I guess, a mashup of the things you find and create things from cutting and pasting and slicing things together? Or are you going to do more like Cwits is doing and trying to create everything from scratch yourself?
I'm gonna go with option 1 until I understand the syntax well enough to go to create things from scratch.
Fair.
Because if you go to the other thing in the repository, there is a CSD that's called the lore, and that is actually a sound processor. This is an instrument. Because,
This guy?
And, this guy. And it's a very nice thing. You can you can load your own audio files and you can process them.
Okay, and it seems to be for synthesis for the most part. It's not for any kind of audio processing. It's not like for creating an equalizer or a compressor.
I think somebody made a phaser using Cabbage, so yes, it is doable, because when you are building, it gives you the option of exporting a plugin as an instrument or an effect.
Again, what's that about? Okay, but I get it. So it is.
This is just KKKKK. Maybe he's just too lazy to think of variables.
But the syntax highlighter is picking this up as something different. Maybe it's just an identifier for this opcode or a parameter for this opcode, but it's not highlighting with the same colors as regular variables. So maybe this has special meaning in the language because it's highlighting the same colors as the keywords.
Yeah.
Okay, I'll take it.
Yeah.
I mean, everything is kind of unusual until you get used to it, so that's okay.
Yeah.
But it does not look like anything that we have seen before. It kind of looks like Python to some extent, but it does not look like Python in the sense that indentation is clearly not significant in this case because it's using keywords to end stuff. So it is its own thing. Nice.
Maybe I am drawn to these kinds of weird experimental software. Maybe that's what drew me to DIN Is Noise in the first place.
Yeah, I kind of like it, but I do want to hear from you what got you stuck in JUCE. What did you try to do and what happened in Visual Studio that you didn't make sense of?
I'm going to go to the video tutorial again because I couldn't find the specific menu again. Sorry, my volume was turned up. I'm still struggling with Visual Studio, and this guy is using Xcode.
So you're following along with the audio programmer tutorials, right?
Yeah.
I watched some of those as well. And the impression I got is that he's very much like us. He was like learning in the open because from the way that he talks about, at least in the videos that I started watching, and I just went to the playlist about JUCE and I clicked on it. So it was like videos from 5 years ago. Probably that has
okay.
changed over time, but it seemed like he was trying to make sense of things himself as he was explaining it, which I find, which I can appreciate because I do that a lot over here on YouTube as well. But it's just something to keep in mind that it's not like an expert with a closed package that is teaching you like everything correctly. There are some mistakes here and there in the way that he's talking about things, which is something to be aware of. But I kind of I like this style.
So should I look at another tutorial perhaps?
I don't know. Maybe the later things, the later videos are different. And most of what he was sharing, I mean, you can see that he knows how to make things work. He knows how to write the code that is going to make the plugin work. But there are some concepts that I remember, for instance, he was explaining how a method is defined, or I guess he was explaining inheritance. He was explaining how an audio processor in JUCE has to inherit from a class in the JUCE framework itself, but he didn't really, or at least for me, didn't come through that he was clear on the concepts of what a class is, what an object is, what inheritance means. And those are complicated concepts in and of themselves. In C++ even more so, because there are nuances like virtual versus not, and pure virtual and what that entails. So it's important to take it with a grain of salt. It's like just one of us learning and sharing what they learned.
Nice. So I just ran Visual Studio. Do you mind if I share my screen again?
Yeah, absolutely. You do it, and I will have to press one button or two on my side.
Great. So share screen. There you go. And I'm also sharing the video. So this is where I got stuck.
Okay, hang on. I will have to press some buttons here on my side for it to show up for everyone. So if you don't mind, just give me a moment. Guess that's not the one I want. That will probably do. Shared screen, and then we are good to go. Okay, so we can see your screen. The quality isn't the best, but now that you have big fonts, that works well.
So this guy has opened a folder called widgets, and this is where the oscillator is, and this is where he's doing the editing. And I have typed oscillator in the search, and I can't find this thing anywhere. First of all, this guy is in JUCE DSP. So where is this?
Is this oscillator part of the framework or part of what he is developing?
I don't know. He just created the project and it sort of appeared, I guess, because I followed all these steps.
Oh, okay. So it's part of the framework. It's under the DSP module. And
maybe he has checked some checkboxes when he was building.
Oh, you're right. Maybe
Producer.
I missed something.
Yeah. Can you open Producer? Because I bet that it's a module that you didn't enable. In Producer, there are these modules that you can enable and disable, and you may want to disable. You may think like, why don't I have all of them by default? And the reason has to do probably with licensing. You have to opt into some modules that are commercial. If you want to build closed source plugins, you have to pay a license to use them. But I think what you have to do is just click on the X where it says like new version available, because there is a new version of JUCE, but you click on the X so you can see a little plus sign. And on that plus sign, there will be add a module, global JUCE modules, and look for DSP, JUCE DSP.
There it is. Oh, there it is.
Yeah, and now that you have that, so that changes the project definition. You have to, I think you have to click on the Visual Studio icon on Producer.
Yeah.
And that will update the project in Visual Studio. You may need to like close and reopen. I don't know. I haven't worked with Visual Studio. So in Xcode, I don't think you have to do that. But then that module should be available now.
Okay, choose modules. Whoa! Whoa, there it is. There it is. Thank you guys again. So
sure thing.
In 2 weeks, I will probably do another 1% of progress. Hopefully
Yeah,
more
it
than
is
1%.
incremental, and C++ and audio programming are challenging concepts. So yeah, it's fair that it takes time, and there are these roadblocks that probably people don't expect. Like, I suppose that if the audio programmer Josh didn't mention this is because he didn't really think that people would find this difficult. But yeah, it is challenging.
He expects that you know. Yeah. And I'm going to stop sharing my screen now. Thanks again. And I saw a nice video on YouTube that said that programming. Oh, I'm gonna turn on my camera again. I saw a video on YouTube that said that programming is like learning a musical instrument. Your fingers are gonna hurt.
Pretty much.
But aside from that, it is a skill that you develop over time.
Yeah, absolutely.
So yeah.
It's just one of those things that takes a lifetime to learn. So the sooner you begin, the longer it takes.
Mm-hmm.
Right. So do you want to, like, you're screen sharing, so do you want to share like the things you built and your VM running that synthesizer and everything?
Oh yeah, that thing. Yeah, I can show that if you want, yeah. But I'm gonna warn you that it's going to lag a lot. But,
okay.
But still, I can show it just for fun's sake. I'm going to close Visual Studio, so you can see my screen again.
Mm-hmm.
And I'm going to run VirtualBox. There it is. I actually named my own system DIN after DIN Is Noise, because that's the only thing I built it for. But I am going to install Reaper as well, so I can route its audio to Reaper.
Did you consider using... I'm just curious about this myself, because I have never used it. So there is this thing on Windows called the Windows Subsystem for Linux. I have never used it, but I wonder if it would work for this, or if you really had to go with a virtual machine, because a virtual machine is definitely more annoying to use. You have to virtualize more things, so it means it's probably going to be slower. But the Windows Subsystem for Linux has tighter integration with Windows. So did you try that?
No, I didn't. I actually didn't even know it existed. But yeah, I guess I could give it a shot and see if it works. Because you know, DIN comes with its own set of dependencies that it needs in order to build it.
Okay.
And I don't know if these dependencies will be compatible with this Windows thing for Linux.
Yeah, that's why I'm curious, because I know that it's Ubuntu, or I guess there are other distributions, but you can run Ubuntu on Windows, and then the integration works, I think, well, because I have never tried it myself, but you can even open like graphical applications on Linux and have the Windows interact with the Windows on, I guess, Windows.
Is it like that thing called the Ruby? Is it that thing?
I don't know.
This thing? No, that's a different thing. And can you repeat the name, please? Windows, what for Linux?
It's the Windows
Right.
Subsystem for Linux. It's WSL. It
Oh,
usually goes by
Subsystem.
the acronym.
WSL.
Yeah.
Oh, nice. I'm going to use that. So is that can be built into different ways using JUCE or ALSA. And I used the JUCE just because I wanted to try that first. It was the first option and it works, so I'm not changing it. Yeah, you're right. It is annoying to use.
So while that is firing up, Cwits, do you want to share your screen like you did last time, and you can show us some of the code you wrote, some of the progress you made in terms of like the code?
I can try to share my camera from the phone to show up the real thing, how it looks like.
Oh, that would be awesome, yeah.
But I'm not sure if it will work, but we can try.
All right.
Oh, I have to manage the curations. I haven't tried this yet, so yeah, sorry.
Don't worry about it.
Where is? Should work now. Yay! Hello. Can I turn around it?
Yes, we can see your camera. Just give me one moment to.
Yes, of course.
Put things here on the screen. So
some fancy lighting.
By the way, do you remember in the previous video live stream where my camera froze in the final 5 minutes?
Oh, really? I don't remember that.
I think no one mentioned it.
Okay. I did mention it myself on the Discord.
All right. Yeah, we can see your Ableton Push.
Great.
Yep. Oh, nice. Nice.
So fancy lights, looping.
All the animations in the lights you coded?
It's not pretty hard to code. It's just a bunch of integers going through one function. But yeah, it's not the interesting thing. So what I have managed, I have just 3 modules, like a simple player, low pass filter, and the delay, which you see previous time. So what I have done, I have made some browser for the files. I have to rotate. No, better this. Yeah.
It's good this way. Yeah.
With this browser, I can look my file system for some audio files. I tried to make it like Ableton-like. I don't know. So yeah,
this is amazing.
But I also can search for those audio instruments and effects. So if I want to add simple player, I can press button to load and it will show up. So nice. I can go there and through that browser, for example, some loop. Will it? Yes.
Wow.
I can load the audio file there. I can little bit stretch that waveform to watch what happens there. And of course, I can play it. I can do some fancy things. Yes. So what else? I can connect that modules between themselves. For example, I want to send that player to the low pass filter, and then separately to the delay. And then those modules I can send to the mixer, where they will mix together, and then they will sound. Yes, but for now I don't have external speaker for my Raspberry Pi, so we can't hear it. But believe me, it's playing. I can press play button and the green thing will go around. This means that this is playing. Something like this.
Man.
And yes, for 2 weeks. I think this is more than I was expecting from myself in the previous hour meeting. But it's great. And if I will keep this tempo up, I hope I will keep this tempo up. That will be also great. Of course, I can delete them. I can do some. Oh, I have some bug here because for now I can't get for the next simple player. I don't know why.
Did you get to a point where you started making music with this, or even just playing around with the samples, or is you like in testing mode?
Sorry, in what mode?
In testing mode. Are you just testing the software to see if it works, or are you already using this to have some fun?
For now, I'm having some fun. It's pretty far away from the making music because there I have to record some MIDI and know how to play them back. And I have to write that code which will do this. And it's also not so easy.
Cwits, do you know Fluid Synth?
Yes, I have heard about it. It's like a Linux synth, something like that.
Oh no, that is a library that you can use when you finally get to building that MIDI thing. You can use Fluid Synth, which is a library that allows you to load Soundphones in order to play the MIDIs. So you can encode your samples in SF2 format. There are some free software that you can use to build that. And then you can load the SF2 and the MIDI file into the Raspberry Pi, and you can play it through Push.
Oh, I can use it for...
I'm going to post the link in the GitHub repo in the chat. 1 second, please.
And of course, some fancy lights there. Which one cool? Which one is cool?
Yeah.
So yeah.
Fluid Synth and Fluid Light. People even have made Android ports
my
for
camera.
Fluid Synth or Python vocals. Yeah. I found Python binding.
And in terms of the code that you wrote to make all of this happen, do you want to talk about some interesting parts, something that you found particularly challenging?
Sorry, for Fotis is a little bit lagging, I suppose.
Yeah, probably because of the VM he started.
Maybe. Definitely,
I did load it.
Yay. Definitely, I have to check Fluid Synth. Maybe it will helped me to build my own MIDI editor, I suppose. Yeah, thank you. And because it will be a good challenge for me.
Oh, sorry.
Okay.
Yeah, I'm here on this Fluid Synth page, and I'm not sure I understand what this is about. Can
you have already gone a long way, man. It's very impressive what you did there. Have you ever heard of Soundphones, Leandro?
I have heard of them, but I'm not sure I know what they are.
To put it very simple, think of it as a bunch of wave files compressed into one little thing. So it's contains samples of instruments, and they all have a binding to the program work. So Windows comes with a sound font, Mac comes with a sound font, and if you load this thing into Raspberry Pi and you encode those wave files as a sound font, you can program the MIDI channel to load specific instruments for specific MIDI programs. So that number one is always a piano. Number two is always a right piano or what.
I get it. So the same way that a font is a bunch of drawings for glyphs, and then text is just the letters that you have to write to make the glyphs appear on the screen. The sound font is a bunch of sounds, and you can trigger the sounds with MIDI.
Exactly. And actually a few contact libraries that work in the same way. Sorry?
It's looked pretty interesting.
And I think the freeware sound font creator is called Polyphone, and it's open source. So hold on, I'm going to post the link. Oh, there it is. So, oh, it was updated 2 days ago. Nice.
Great.
So you can use this thing to load 16 or 24-bit wave files. You have to make sure that the wave files are conforming to a note on the keyboard.
Okay, so the sound font is this idea of bundling sounds and triggering them with MIDI, and Fluid Synth is the rendering engine, I guess. The same way that there is a rendering engine for text
in the
operating systems. Oh, let me say hi to Tail, who is here. Hello, Tail. Great to have you here. We will have questions about C++ that you, or at least I will have questions about C++ that you'll probably be able to help me out. And Bo has a question. What skill level is JUCE at? Is it for advanced, intermediate, or beginners, or for gurus? What is your impression?
I think it's definitely not for the beginners, because you have to know about classes, namespaces, and different things. But I'm not sure.
Yeah, I think that there are different ways to look at this. If you think about it from like the perspective of C++ is a complicated language, then yeah, probably C++ would not be the best first language for anyone. I don't think it's a very friendly language because you have to think about memory allocation and deallocation, and you have to think about concurrency when you're doing audio programming. All of those things are complicated, but if you just work with the framework, it's going to smooth a lot of things out for you. And in audio programming, you cannot do too many fancy things at once because you have to deliver a sample 48,000 times a second. So there are many abstractions and complications in C++ that you can sidestep to begin with when you're using JUCE or any of the other frameworks. The same is true of iPlug, the same is true of any other one. So it's just, you can go into the process block where you will have an array of samples and you have to produce an array of samples. And that in that block, it is not too far from JS effects. It is not simple, it's not easy, but it's certainly something a beginner can grasp. And then you can always grow because JUCE is used in industry. It is production ready by all means. So it's definitely something that you can take along with you as you progress. That's my take on it. And there is also another advantage of C++ and JUCE, that the community is big. There will be lots of people in the forums, there will be lots of tutorials, there will be books. So that's an advantage. But that said, it's a complicated language. So I guess it's amendable to beginners, but it also tailors well for advanced programmers.
Yeah, I'm going to showcase DIN a bit, and then I'm going to turn it off because it's taking up a lot of CPU power. Can you hear my sounds? Can you hear the notes?
No.
I think no.
I thought I pressed the button that allows you to share my audio, but I think I turned it off accidentally. Hold on, I'm going to do it again. So you press here. Oh, there it is. Share system audio. Yeah, I found it. Can you hear now the beeps?
No, still nothing. Oh, now I hear it. Yeah.
Oh, yeah. So DIN has 4 modes. There isn't a free evaluation mode if you want to try it in Windows or Mac. It's free and it has fewer features, but you can still use it. So the 4 modes is, first of all, the traditional keyboard. And if I move my mouse while pressing a note, I'm doing pitch bending with the mouse. That's the one option. The second option is the microtonal keyboard. And I forgot how you trigger it. You press the space bar and it generates a note. And by moving my mouse again, so you play it like a theremin. And
Really interesting.
but these are level 1. Now let's go to level 2, and this is called Mondrian. Yes, it's obviously inspired by the designer. And here you can create music with balls. No, really. I'm not joking. So you create this rectangle right here. Hold on, where is it? So yeah, let's create a record. So this thing is bouncing and it creates notes. And now I can, there is an option to randomize the splits. Where is it?
Oh.
I guess the Skype call is adding its own coloration to the whole situation here.
It can be possible.
Yeah, I think that we lost Fotis at this point. Probably his computer couldn't take it being on the Skype call as well as running a virtual machine. And no wonder, because it's kind of heavy to do all of this at once.
Yes, of course. But we can hope that he will come shortly back.
Yeah, I'm sure that he will come back in a moment. But meanwhile, Cwits, I had this question that I don't think I actually got the answer for, which is in the process of creating all this impressive demonstration, what are some of the interesting things you learned along the way in terms of like the code?
Oh, pretty hard question to answer because I really can't.
Sorry, I was kicked out of the Skype again. I'm sorry. What did I miss? I turned off VirtualBox.
We can hear it.
Yeah,
Awesome.
that sounded like an interesting demo and right up your alley in terms of things that make weird sounds based on physics, I guess. And I will want to ask you more about this, but I was asking Cwits about the process of creating the demo that he showed us and what were some things that he learned in the process.
It's hard to define what I have learned exactly, because I think I have learned not a lot of things, but a couple of them. Yes, for example, little bit about shared pointers in the STL library of C++. Little bit about how move semantics works and where to use it. I have one.
Did you run into any surprises when using these concepts? Because they are kind of complicated to grasp, at least to begin with. So any place where you were like seg faulting or something?
It was seg faulting before I started to use it. For example, I can try to share my screen. Is something sharing?
Yes, it's working.
Mm-hmm. Yeah, I can see.
For example, that simple player, I have two places where I referring to the one audio file is the process function where I use data from file to copy it to the next out buffer, and that drawing function where I draw file, and the not behavior but advantage. One second. The thing where shared pointers help me, that this is two different threads. The copying buffer to the next audio module and drawing it this is different threads. And when I, for example, delete that file, this thread where I drawing it still containing the pointer to that file, and in exact drawing function I had the segfault error, especially I think in these two lines. But with using shared pointers, it keeps alive while these things are drawing and I don't have segfault more now. Yes, I suppose.
So can you briefly explain what the shared pointer is doing?
Yeah, I can load. Oh, I got another segfault. I don't know why for now. Have to manage it. Yes. The main idea of a shared pointer is when you referring to the pointer with the constructor, the shared pointer got inside a local counter, which counts how many references of this pointer you have. And this counter will keep this pointer alive while counter not equal 1, I suppose, or 0. So the pointer is destroyed and memory is freed only when the one shared pointer is there. Something like that, like it.
So I guess the idea is that there is this resource. In this case, it's a file, but it could be any other kind of resource. And
yes,
then there are all these pointers of different, I guess, threads of execution that have access to this resource. And the shared pointer is taking, it's keeping track of how many people or how many threads are accessing the resource. And when the last one goes out of scope, then it will know to call the destructor for that resource.
Yes.
And of course, this falls apart as soon as there is any sort of circular pointers, like two resources pointing at one another. If you are using shared pointers for that kind of situation, there will always be one pointer alive, but they are just referring to one another. And when they both go out of scope, the thing would leak. So a shared pointer is only to help you out, not to solve all the problems in terms of memory management, right?
Of course. As you saw, I still got some segmentation faults, and I don't know why. So we have to continue to research things. Yes, this is one thing what I have learned and I'm using move semantic here when I building the first reference of shared pointer, and in the file factory I have the vector of all files loaded in the program, and I have to use move here because of when I'm out of the scope of this function, this pointer will be destroyed.
So you're just transferring the ownership of that resource to the other method.
Yes, I think, yes. So, something like that. I'm not so good at this still, because I have read it in the internet that this will help you, and this helps me.
Okay, I get it.
Another interesting thing for me was, as I mentioned in previous time, I want to manage how to build proper, I'm calling it a render map. The idea of it is to render things in correct order. Because, for example, if I have a simple player connected to the filter, I have to render simple player earlier than filter. Because of if I do opposite, the filter will receive empty buffers and it will do nothing.
That makes sense. Yeah.
And because of I wanted to make things like modular when I can connect things between themselves as I want, it was a little bit hard for me to manage, but somehow I have done this and it seems like working.
I love line 382. Can you scroll up?
This one?
Yeah, I don't know how or why, but it works. So yeah, I guess what it boils down to is you have all these modules like the sample player and the filters, and I guess you have others like delays, and you have to build. To be fancy, you have to build the directed acyclic graph of the modules. You have to know what modules depend on what other modules so that you render them in the right order. And I suppose you can even parallelize some of them if they don't depend in one another. If you are sending, like in your demonstration, you had the sample player sending audio both to a delay as well as to a filter, I think. And in that case, you can parallelize the work of the delay and the filter. But then if they are mixed back, then the mixer will depend on the two of them. So you could start different threads to compute all these nodes, and you have to manage how they relate.
This is too far away from now, but I think, yes, I can make it. And this will be pretty interesting also. So, yeah.
And right now you're just doing this, I guess, in a single thread, and you are just making sure that you're computing things in order, right?
Yes. All audio things, all the copying and the filtering and the delaying stuff is one thread for now. Maybe someone later I will parallel them, maybe. Because I have 4 cores in my Raspberry Pi.
Yeah.
So it will be.
I still think that it's awesome that you have made this tiny little functional modular system. Imagine the possibilities. You can create all sorts of, you can implement source code from existing filters or effects.
Yes, of course. This is also a part of plan to implement the LV2 plugins and maybe VST through Vim, or how it called, Wimp. I don't know.
Yeah.
But this will be someone later. But this is a good idea. Why not?
Yeah. Hopefully, Cloud will bridge.
Well, of course. But also,
Leandro, I did watch the. Leandro, I did watch the Geeking Out with Justin Frankel video, and now I'm watching the Geeking Out with Schwa.
Yeah.
So you guys had a great time.
Yeah, it was very nice of him
angry
to.
That I missed streams.
Yeah, it was very nice of him to accept our invitation, and he is a great guy. Right, and Fotis, I had a question.
Justin and John are great guys.
Yeah, they are. I had a question for you, Fotis. You built this thing on the virtual machine and everything. I wonder how the process was, if it was just downloading the thing and running make install, or if you ran into problems.
Oh, I can guide you through it because there is a guide on the official website. Mostly it was a matter of downloading things, like you said. Where is the README? So you click on download, and yeah. So if you go to this thing, this is the exact same README that you get when you download the source code, which you can find in this link.
But there is no source code. There is a rebuilt libraries. Oscillator, so it's
No,
not
if you
really
scroll down, you can find the build DIN Is Noise from source code in GNU plus Linux. You download the complete source code from Internet Archive.
Oh,
It's on the second. Yeah.
oh yeah.
That's interesting to put the source code on Internet Archive. I was not expecting that.
Yeah.
I just didn't scroll down.
Yeah, so you install those libraries and then you run the commands. Now, as for the problems I had, I think the only one was finding OpenGL, but I think with a few Google searches, I found everything that I needed.
Yeah, this is a fairly short README, and it's a fairly standard process. You download the dependencies, you run configure, make install, and for people who have been building software from the command line, this is pretty much what you would expect.
Yeah.
Awesome.
It's pretty straightforward, yeah.
Now, do you want to see what I did?
And by the way, you should... yeah, but first you have to you have to respect the developer's request. He says in some place in the website that you must not use the source code to build and distribute Windows or Mac builds, because he needs the money, he needs your support. Yeah, I think it's something, but I totally respect that. I understand where he's coming from.
Yeah, fair enough. And
it's not like him. It's down below.
It's not like he made the process arbitrarily complex for people who want to build from source. It's fairly standard. So good job on making things easier for people who do want to build on the command line. And maybe they still want to support financially the project. So there is that. Do you want to see what I did this week or these 2 weeks?
Course.
Yeah, so I said that I am working on this auto mixer. One essential part of it is computing RMS, and there is something in JUCE that allows you to compute RMS. Unfortunately, it can only work on a block of audio, and I want my RMS window to maybe span over across multiple blocks of audio. Like maybe my block size may be 256, but I may want to have RMS of the last 1 second worth of audio. And in that case, I cannot just use the thing that comes with JUCE. So I went over the code base and I started by cleaning things up, because JUCE generates a lot of boilerplate that I didn't actually need, like some comments explaining what things did. I cleaned all of that up. Now it fits on one screen. And even the plugin processor, I reordered some things just to make sense of what was going on. Like the MIDI stuff is grouped together here at the top. And over here on the plugin processor implementation, the same MIDI stuff you saw there in the header, it was using a bunch of compile time flags and the preprocessor, and not compile time flags. It was using macros and the preprocessor to write code that was overly generic for what I needed, so I just cleaned things up. I think that makes things easier to read. But the meat of what I did is over here, and you can see that there are a bunch of issues that I want to talk about. But what I did is I wrote this code that is going to compute RMS by hand. So instead of using the function, I think it's called like buffer get RMS something something, get RMS level. Instead of using that, I am sort of recreating what that does by hand. So the way that I did it is I have a list or an array of RMS or an array of squares of samples, and I have a running sum. And this array I'm going to treat as a circular buffer. And the running sum I update by saying I want to add the squares of the current sample that I'm looking at. And I am being smart and I'm adding up all the squares. So you can see that I'm taking the power too. So that's a square. And I'm adding up all the channels after squaring them, because you want to combine channels with their power, not their amplitude. And then I subtract the old square that I had in that list. This is an algorithm that I implemented before in JS Effects. There is a video like 1.5 years ago, something like that, in which I implemented this algorithm. So I won't get too deep into that. It's just, it boils down to a circular buffer and a running sum that I update. But there were some things that I'm not quite happy about. The first is, after I built this and I loaded it in Reaper, I noticed that just this, it's just computing RMS. It's taking 0.1% of CPU. That makes no sense. It's such a fast and simple thing. It was not supposed to be taking any CPU at all. And then I ran some audio through it, and I noticed that the CPU use went down. There is something here that is supposed to take care of denormalization. It's supposed to take care of values that are so small that they take up a different path on the CPU, and that's slower. So it was supposed to be taken care of by the framework, but it doesn't seem to be. I have no way of proving that it's denormalization, but it seems to be denormalization that is the issue here. So I have to look into that. The second issue that I had is that I'm not happy with the fact that I had to write this by hand. I really wish that there was a way in the framework to compute the RMS of arbitrary windows. And yeah, I know I would have to push samples into the RMS computer, the RMS, I guess, the routine that is computer RMS. I would have to manually take the samples from the buffer and push them into that object. But it doesn't seem that that object even exists. It seems like the way of doing it in JUCE is to compute it by hand, the same way I would do it in JS Effects. That seems weird to me. I couldn't really understand what the space looks like. Is JUCE just for smoothing out the differences between the different APIs like VSTs and audio units? Wasn't it supposed to also give me a hand on the algorithms part of things? And I know that it comes with simple filters and everything, but RMS seems like such a simple thing that it is weird that I have to write this by hand. Then the third issue is that when I loaded this the first time in Reaper, it crashed. It didn't crash the plugin, it crashed the DAW.
Oh.
But then it didn't crash again. I loaded it again and again. I ran some audio through it. It didn't crash again. So that is weird. And this fourth issue is just I went in Producer and I changed the name of the company and the plugin and everything. And I think that in Reaper, I need to refresh that. I need to like throw out the cache and reload for the company name to be updated. So that's nothing too crazy.
Actually, there is an easier way to do it. Reaper is storing all the information about your plugins in a separate text file, which you can find in the Reaper installation folder. So if you open that file with a text editor and replace your company with the name, I think you should be all set.
That's a good point. I will quickly go into my Reaper configuration folder and do a search for your company.
But after rescan of plugins, Reaper will not overwrite it. Override?
Yeah, it seems like when I compile a new version of the plugin, I have to close Reaper and reopen it. I couldn't find another way of doing it. I have to close Reaper and reopen it for it to pick up the new version of the VST file, for it to pick up the changes I made in the code. Then I guess Fotis is right. I can just come here and delete this line from the configuration because this seems to be the place where Reaper is storing or caching this information. But that's all right. It's just a quirk. I don't really care about it. I do care about the fact that I have to reopen Reaper every time. That's annoying. And Dale is telling me something interesting about the denormalization issue, which could be because of the algorithm and the way that I implemented it. Because the way that I'm doing it is I have this running sum and I never reset. So I'm accumulating floating point errors into the sum. As I add things up, I am accumulating floating point errors. And when I'm subtracting, I am not guaranteed to get rid of those errors, because in floating point numbers, when you say plus x minus x, it does not necessarily mean that you get back to where you started. Because of the floating point errors, you may have a value plus x minus x does not get you back into the original value. So that could be the origin of the denormalization problem. Yeah, I will have to look into that. I was expecting this to be more magical than it was. And I was expecting JUCE to be more magical than it was in terms of having RMS of arbitrary window sizes. And I guess the general lesson that I took from this is that JUCE, it will not help me as much as I was expecting. I was expecting that JUCE would have all these components off the shelf. I could just take them and start using them. But it seems like it is a bit lower level in the sense that it does come with DSP objects for compressors and equalizers and everything. But even for something as simple as computing RMS of arbitrary window sizes, it seems like you have to do some of your own reinventing the wheel, I guess. And of course, there will be libraries and other objects that I can pull from other places that will do the things that I need. But it doesn't come in the box, it doesn't seem like.
Yeah, that is a shame, because RMS calculation is such a crucial thing, you know?
Yeah, and I guess it kind of comes in the box. I guess it comes in the box because it is available in the buffer class. It's just that when you need something that spans across multiple blocks, multiple buffers, then you are out of luck. And
do you have to do the same thing?
Sorry, you were going to say something?
Yeah. Do you have to do the same thing if you have to make a switch, if you want an audio plugin that you can alternate between calculating peak or calculating RMS? So you have to reinvent the wheel twice?
Yeah.
You have to create a separate thing for peak measuring.
Yeah, and JUCE does come with something that does ballistics, so that does attack and release. So I hope that I will be able to use that when the time comes, when I'm doing some sort of smoothing out of values that needs that, smoothing out an envelope for a compressor, for instance. Luckily for the auto mixer, I don't need that. The auto mixer doesn't really need the concept of attack and release, doesn't need any of that. It's not peak sensing in any way. It doesn't really make sense for the auto mixer to operate in that capacity, I don't think. Not my auto mixer will not do that.
One more question about the auto mixer. Is it going to use LUFS, LUFS?
It may. Right now it's not. Not even the JS Effects version. It's using RMS, and it seems to be good enough. The only difference between RMS and LUFS, well, there are two. The first is that in LUFS you filter before you take the RMS.
Yeah.
And it doesn't seem like that is something that comes up. People don't really ask for that. It seems like RMS is good enough. You don't really need the filters because the auto mixer is going to be used mostly for voice. Or I guess only for voice. It doesn't make sense to do auto mixing of anything else. So in that scenario, LUFS and RMS are close enough that it doesn't really matter. And I guess the second difference is the window size is fixed. Momentary LUFS is, I guess, 400 milliseconds. Short term is 3 seconds. And over here in the auto mixer, I think it makes sense to give the window size as a slider, because depending on your application and even on the people you're auto mixing, depending on how they behave, how they crosstalk, it makes sense to be faster or slower. So it makes sense to have a smaller or bigger RMS window. And the user seems seem to be happy with that in JS Effect, so I think I will keep that here as well. But yeah, I guess the general lesson is maybe JUCE, maybe I didn't get it in the sense of getting it yet. Maybe it doesn't do all the things I was expecting it to, but still, I got RMS computation to work, hopefully, because the sixth issue is I don't really have a way of proving that this is computing RMS as it should. I'm computing it and I'm dropping it on the floor. It's an unused variable. I think I should attach it to some sort of slider so that I can see it moving around. Or maybe I will be able to draw something on the screen or something. But for now, I'm just dropping the value on the floor. And in terms of processing the audio, I am just muting. So when you drop my auto mixer into a track, it's just muting the thing. So for next steps, I need to show that this is actually computing as it should. I really think that it is because it's fairly basic, but still I want to show that this is computing. And then the next big peekaboo on this project is the fact that the auto mixer needs to have many streams of audio coming in. It needs to compute the RMS of several tracks, of several microphones, several people. And usually, I mean, in Reaper, we have special powers because tracks can have 64 channels. And the way that I do it is I just put the auto mixer in a track that has many channels. And then I use Reaper's routing to do the heavy lifting. But in other DAWs, that's not the case. So I will have to look into how to do inter-plugin communication. I think that this is the only way to do it. It's the only way that I know other plugins do it. So there are plugins that do this. There are auto mixers that do this. There is an auto mixer by TB Pro Audio. It's called the AMM, the Auto Microphone Mixer, something like that. And it works like this. And there are other plugins like Neutron by Isotope. It's not doing auto mixing, but it's helping you mix. So you just drop, the way that this works is you drop one instance of the plugin on each track. So on each microphone, on each person speaking, you drop one instance of the plugin. Each instance of the plugin is sending audio to another instance living on a sort of a bus. And that is receiving the audio from all the individual microphones, and that's where I will have to do the auto mixing for real. So this inter-plugin communication, this sending of audio from one instance to, I guess, the manager, the mixer, that seems challenging. I don't think that many plugins do this, so I don't expect to have a lot of resources in terms of learning material, and probably not a lot of support from JUCE either on this. So that will be interesting, and I may get into that in the following 2 weeks. But mostly I would just try to make sense of how to wire this into a parameter that I can show the RMS computation working. Probably I want to have a slider for the RMS window size, because right now it's fixed at 48,000 samples. And I probably want to have that as a slider in terms of milliseconds. So I'll have to look into, maybe JUCE will have the multiplication somewhere for me. Like I know that it has dB conversion. And another thing that I actually want to run by you all, because you know more about C++ than I do. When I'm doing this, I don't have to initialize the array, right? It's going to initialize it for me. As it instantiates the object, it's going to initialize it for me, right? So this is fair game, right? It seems like no one knows the answer.
I should, Cwits, I think your microphone is muted. Oh, there you go.
Sorry. Hello.
Hello.
Okay, you can hear me now.
Yeah.
As I know, it depends on if the object is allocated on the heap, then not all variables can be initialized, but I'm not sure. Maybe you have to check somehow this thing.
Yeah, Tail is saying on the chat that no. I guess no in the sense that no, this is not fair game, and I should be initializing this explicitly.
Maybe. I know that if variables is allocated on the stack, then they are initialized with zeros.
Oh, I should memset myself, Tail is saying, but memset is for when I already have that chunk of memory and I want to set it to 0. So you're just saying that to begin with, this is going to be junk. That's a good point. But my question is even more primitive. Do I need to allocate this myself, or when this is not going to be allocated on the heap, I don't think. Let me check, because it's actually here. No, it will be allocated on the heap. But I was expecting the initializer to take care of this initialization for me. And then it will be a junk, and then I have to probably over here, when I have a chance to do some preparing to play, I probably need to come in here and say that my RMS squares is going to be probably man's, not equal to, but probably man's set. And I don't really know this function, so can I have some help here? Memset of the pointer, the value, and the length. So it will be something like this.
But the length should be like 48,000 multiply of size of the variable. You have floats, so multiply the size of the floats.
Fair point, yeah.
But this was like it was in the C. I don't know how it works in the C++, but I think it should work like this.
Yeah, but this is just to make sure that the memory in there is not junk. I guess because the thing didn't crash, well, it crashed once, but it didn't crash every time. It means that probably the memory is there for me to use, right? And Bo is saying, are you storing every sample in the array and calculating an average? No, I'm not storing every sample. As samples come in, I take the squares of all the channels, left and right, because in my plugin I only support mono or stereo. So in case it's stereo, I will add up the squares of left and right, and that's what I store in the array. I already stored the squares, because that's what I will need later to subtract to get back to where I started. And Bo is mentioning that there is an option of doing an exponentially moving average with 2 running samples, or actually just 1 in this case. I could just compute this RMS, and instead of doing this, I could compute the squares of the channels, and instead of doing this thing, I could just accumulate using an exponential moving average. But I don't like the way that it works out. I have a video, again, probably 1.5 years ago, another video, in which I compared this kind of algorithm with exponentially weighted moving average. I liked these results better. Maybe because I couldn't really make sense of the time constant to make the 2 algorithms closer, but I looked at some other people writing similar code and I couldn't really find a way to make it work. It seems like in their code, it's also very different to really compute RMS, like this is doing, and even what JUCE is doing, and using the exponentially weighted moving average approximation. I didn't find that the approximation was good enough for the purpose of the Automixer. So that's that. Right. So
I would like to make 2 comments about Automixer.
Yeah.
But first, we were discussing Soundphones and Polyphone, and just out of the blue, I just got an email that Polyphone got a new version. It's super creepy if you think about it. Anyway, now the 2 comments about Automixer. First, you mentioned about the inter-plugin interactivity, and Air Windows has those sets of plugins called console. They are for console summing that are emulating analog saturation in console summing. So they work as such. Each console plugin has 2 separate plugins, the channel one and the bus one, sort of like Neutron. So you place channel at the end of each track, and you place the bus one as the very first plugin on your master track. So the channel plugins are distorting the signal, and then the bus plugin is undistorting the signal, is applying their inverse, and this helps the sounds gel. I don't know the basic work, but how they work internally, but this is how inter-plugin compatibility works here. And there is a similar one by Analog Obsession, but it works in a very straightforward way. You just place the thing in your master bus, and then you route all the Reaper tracks into it. And I have mentioned this thing that I posted on the chat in a previous video, and I couldn't remember why this was the only plugin that Analog Obsession made that is not available as VST3, only as VST2. All of the other ones are VST3 available, both on Win and Mac. But this one, this NCAR thing, if you scroll down, you'll see that he's not using VST3 or AU because of the input and output limitations.
Well,
so maybe
it has VST3s. Yeah, it's here.
No, this is the SE one. I'm talking about the regular one.
Oh, what is SE?
This is a simplified one that only gets one input and one output, one stereo input. So it functions like your usual channel strip plugin. Okay. But this one, yeah. And I did use the VST2 one, and it can accept up to 8 inputs, as you can see here. Yeah, I think that's possible in Reaper. It's even showing here in Reaper. We can see the Reaper user interface behind the plugin. But I don't think that other DAWs have support for multiple channels like this. I don't think that you can have tracks with 64 channels in every DAW. So I don't think that this architecture is going to help me out, because if I want people who use Reaper, I already have the JSFX version. So yeah, interesting. I will look into this. Unfortunately, the Analog Obsession plugins are not open source, and maybe the only version is VST2 because of a limitation in the VST3 API. I don't know. Yeah, and even the audio units. That was what really surprised me, because according to what Chris from Air Windows told me, you can create audio units that have infinite inputs and outputs. They're called end-to-end. So I don't know why Analog Obsession couldn't create an AU out of this. And the other thing I wanted to say is, because you said that the auto mixer is actually dropping the CPU load once you actually play audio through it, right? You said that silence is consuming more resources than actual audio, and you thought that it was a fault of the denormalization. Now, this is a shot in the dark. I don't know how to fix this, so I'm going to mention TPDF dither just because of its architecture. It's the most standard dither that they can make, but it works in such a way that if you play silence into it, it doesn't process audio at all, similar to what VST3 is doing as a format. Did you export the auto mixer as a VST2 or 3? 3. Oh, yeah. Then it's very weird that it's doing it. Sorry, I have no idea. Yeah, it may be what Tail said, because I am accumulating floating point errors in here, and that cannot be good. So I guess one way of handling this is maybe just flushing to 0. So I don't really want to do this, I guess, because it's probably a bad idea, but something like this will do. Where I just flush to 0. If the value is small enough, it's 0. And then that may get rid of the
performance issue. But Tail is telling other interesting things about the memory allocation that I was pondering about. So yeah, the memory is allocated for me, and in this case we are talking about this memory. It's being allocated for me. However, he's not sure if you can use arrays of arbitrary size like this. There might be a limit. Interesting. I wonder how that limit will show up. If it's not going to compile, or if it's going to compile and segfault, or if it's not going to segfault in the first 3 days, but only when it's noon and Jupiter is in alignment, it will segfault. I wonder how that will look like. Oh,
is this auto mixer going to be sample rate dependent?
I don't want it to. I really hope that I can get rid of these variables. I mean, probably I would just allocate this conservatively to be very large, or I will allocate this dynamically over here in the prepare to play where I have access to that. Because it's fair to allocate memory in prepare to play. It's not a great idea to allocate memory in the process block.
Yeah, you could implement some sort of undersampling, so you can ensure that the plugin will sound the same no matter the sample rate.
Yeah.
That's also how Chris from Air Windows solved the problem.
Sorry, can you say that again? I don't think I get it.
Yeah, Chris said that he had trouble with some plugins that he created that they sounded different in 48K and different in 96K. So he implemented an undersampling algorithm, and so the plugins now sound the same no matter what sample rate you use.
Yeah, undersampling, that's kind of interesting. I don't think I will go for that, though it wouldn't be too hard, but I don't think I'm gonna go for that. Okay. I think I would just try to keep it simple and see if I can do with just one array like this. Maybe I will even go to the exponential moving average just to get rid of that memory allocation, which is a good idea anyway, because it is faster, it is not as prone to some of the other issues. Well, the floating point errors accumulating in the variable will be an issue anyway, but still. And at least in Visual Studio, it is going to just fail to compile if this if I make this number large enough. But I think it will be okay. We'll see.
I should remember not to do that.
Oh, better to allocate variables in the constructor and delete on the destructor. But there is a problem. If I want to be conservative and think that people are using 192K as their sample rate, then I can allocate conservatively and do that on the constructor. But the constructor doesn't have access to the sample rate, and the prepare to play has access to the sample rate. So the trade-off, I guess, is I can only allocate more memory, but I can do it once when the plugin is loaded. Or every time you hit play, I will need to go and allocate a chunk of memory. But the chunk of memory is rather small, so it shouldn't matter. Yeah, I guess it doesn't really matter if I do it one way or the other. And there is this person who, are you a human being? It doesn't sound like you're a human being. Yeah, I can't send a word through serial.
The bots are getting smarter.
I mean, are you talking about a word as in computer science word and through a serial port? I don't know. And if I feel playful, double the square of the sample values you sum and then double the square root of the result. Also sounds cooler. Okay. I may. It's always fun to play around with these things. Though I think that when I'm playing around with algorithms like this, I will probably do it in JS effects. It's much easier. And the feedback loop is much faster because I just save and it's there. And here I have to build, I have to reopen Reaper, I have to put the plugin on the track. It's more annoying. Right. So for next steps, making sure that there are some sliders. I hope that I can use sliders as outputs the same way that I can do in JS effects. Hope I can do that here in JUCE. So prove that the RMS computation is doing what it's supposed to. Maybe have a slider for the size of the RMS window, though that is kind of annoying because I will have to change the computation here. As the slider moves around, I will have to traverse these RMS squares and subtract from the running sum or add back to the running sum as the slider is moving. So it's kind of annoying to implement, but I may. But definitely I need to look into how interplugin communication will pan out. That's my plan for the next meeting. Fotis, how about yourself? What are your plans?
Well, I'm gonna keep struggling with that JUCE tutorial and maybe watch some other things. And even Chris from Air Windows posted some live streams called DSP coding for beginners. So I will take a look at that. You can see them on his YouTube channel, youtube.com/airwindows. And if you look for DSP code for beginners or C++, I don't remember the title, but you can just type beginners and you can find how he does things. And I think he's using a similar route to what Cwits is doing. He's not using JUCE or any of the stuff. He's making things from scratch.
Prince?
Sorry?
How was his name?
Air Windows. His name is Chris. But if you go to youtube.com/airwindows, and I can post it on the chat if you want. Beginners.
I suppose you're talking about this video, right?
Yeah. And he made one more. Yeah, oh yeah, that's the one, yeah. No, that's the only one that he did, yeah.
And here is someone else talking about the console plugin you just mentioned, and you can sort of see in the thumbnail many instances of the plugin, probably sending to probably sending to some other place.
Yeah, I use it a lot and I love it.
Yeah.
And remember what was the first thing I told you when we met, Leandro?
No, I don't.
It was in the chat, and I told you, Leandro, you're a saving Reaper. And you said, from what? Because you were making JSFX. And I have requested for you to port the Air Windows plugins in JSFX. And somebody already did one, 2 of them, in fact. I don't remember the name of the JSFX, but he ported the purest gain and bit shift gain into JSFX, and I love how he did it. He created custom sliders and Chris loves that. He loves it when people take his code and create some other new interesting things from that. And Chris has started to use the Reaper a lot more lately, so maybe I will nudge him to make some JSFX. Hopefully I will persuade him, because he's a programming genius, so I can't wait to see what he makes with JSFX. And so to finish my long parenthesis, so yeah, I will watch these videos that I said, the JUCE one and the Air Windows one, and also no matter what, I will keep going with Cabbage, and I will do some Frankenstein experiments of plugins by stitching code from other things and see what comes out. maybe I'll make DIN Is Noise too.
Sounds like
DIN
fun.
harder.
And I owe an apology. This was talking about sending
This was a
words
person.
through.
Sorry.
And the person is a human. Thanks for being here. And I really had no idea what you were talking about, like sending words through a serial, probably sending bytes through a serial port, but trying to communicate with a microcontroller via USB, and Python keeps importing the incorrect library. I'm sorry to hear that. I hope you can figure it out. And yeah, it's probably something to do with how you are integrating the system, like how you are using Python, which version of Python, which version of the library. All of this affects the results, and it can be complicated and annoying, as Fotis can say, because he was not importing one of the libraries that he was trying to use. And then the code didn't compile.
Yeah.
Right. And Cwits, plans for the next meeting?
As always, plans is very huge, and really I don't know. I have so many things to do in my head. It's hard to decide from which to start.
Give us like two options and we can help decide.
Two options. Maybe some more proper MIDI routing things. Keep improving other things. I have already some code snippets for sampler.
Oh.
From the previous iterations of this project, so I will try to implement it for the next time. And maybe start to understand how Fourier transform working. It will be difficult topic, especially.
Leandro has done it.
Yeah, I do have a video if you want to check it out. Of course, it's in JS effects, not C++, but the concept is there, and it's similar enough that anyone who writes C++ will be able to read JS effects. And I did create not the fast Fourier transform, but the discrete Fourier transform, which is the simpler version, the slow version. But I did go into the theory of why it works, how it works, and what it does. Great. And then if you do want to implement FFTs from scratch, there are plenty of sources. I didn't actually go into that yet, implementing FFTs, but there are good resources explaining all the algorithms, the butterfly mechanism and everything. And then if you're only interested in knowing how the Fourier transform works, like the theory, and then you just want to get an FFT implementation and go with that, there are plenty. I think that two that I can recommend are Keys FFT. It is simpler to integrate into other projects. It's simpler to bring it in. Keys FFT, keep it simple, FFT. And then there is another one that people use called FFTW. It's the fastest FFT of the West or something like silly like that. And that one is supposed to be even faster, but it's more complicated to integrate. It's like 100,000 lines of code for implementing FFTs, which is like amazing and crazy. And there are others, but I think that these two are probably the ones that I see more often in the wild.
I know about FFTW and I have used it, so it not have to be the big problem to implement it, but to understand what it does and how to, for example, pitch shifting with the FFT, because sampler have to do pitch shifting, not just playing at one pitch.
Yeah, exactly. It should be able to spread the pitch shifting across all keys in the MIDI.
Yeah, yes, of course.
Yeah, you're right.
And
like an Ableton sampler is doing that.
Of course. And this will be the I think, hardest topic for me, because I wouldn't say that I'm bad at math, but I don't know the higher math.
I have an idea. Maybe you can do this until you figure out how to do the FFT thing and do some more complicated pitch shifting. You can do, just for testing, you can simply implement some sort of repitching. All it does is playing the audio faster or slower in both pitch and tempo. It's the simplest thing in the world. Even in cassette tapes, you could do that.
Yeah.
And it's the pitch shifting that comes across. So you can just make the audio play slower or faster until you find an implementation for correct pitching that keeps the time intact. It's the next best thing.
Yeah, this is interesting idea. Thank you.
No problem.
Yeah, there is a chapter in that book that I am loosely following as I'm developing these effects. The C++ book by Will Perkle. There is a chapter on the voice vocoder, I think it's called. Phase vocoder.
Yes,
that's what it is.
yes.
Phase vocoder. And he explains how this time stretching and even pitch shifting using FFTs work. So you may want to read on that if you're interested.
Nice.
Right. So it seems like we all have enough homework. So I think that's it for this week. Thank you very much for joining me. Thank you, Fotis and Cwits, but also Tail, Bo, and Margit. I hope I am pronouncing your name correctly after thinking that you were a bot. But I'm sorry about that, and thanks for joining us.
Me too. Sorry.
And I am looking forward to having you all here again in 2 weeks. So that's going to be the 29th. Is that good for everyone?
Yep.
Yes.
All right. So looking forward to that. Have fun, and I see you in 2 weeks. Bye-bye.
Bye, everyone. Thanks for
you.
watching.
Bye.
Bye.